Homework 4.4 is a puzzle, and it's a picture puzzle. There is this picture right here, and it can be interpreted two ways. One right side up, and one if you turn it upside down, it makes a different picture. And the titles for those two pictures are right here. And the way you're going to figure out this puzzle is by solving these problems. And these are the consonants. All the blanks are vowels. The answers are right here. These are the answers to these problems. So your homework 4.4 is to solve these. You need to do it on another piece of paper. There's not enough room. And just a mid-year reminder, you should never be starting by looking at these videos. You really want to, at the end of each day, be able to solve all problems by yourself. And if you're needing to use a video, you don't know the problems all the way. And so after getting help from a video or from a friend or from a teacher, you need to later go back and make sure, like, could you do that problem on your own now? Just watching a video and figuring it out with the help isn't the same as knowing how to do things. So just a reminder that you shouldn't be coming to these videos unless you have already completed it as much as you can. And at the end of these videos, you should be going back and getting, like, practicing the stuff you needed to get help on. I'll do a few of these. I'll do number 2, which I think is kind of challenging. There's a 6-foot-tall man. I'm going to draw a picture. He's 6 feet tall, walking at a rate of 3 feet per second towards a street lamp. So he's walking this way, and there's a street lamp that is 18 feet tall. This is not proportional, but here's my lamp, and this is 18 feet tall. He's walking towards the lamp. At what rate is his shadow length changing? So we need to know how shadows work. So if there's a lamp, the light will be shining at him. The light's also shining here. And what happens is the light starts up again, over here. Like there's light. But this part is dark because it's blocked out by the man. And so this is his shadow. I'm going to call his shadow S, that distance S. And I'm going to call this distance right here, this is changing also because he's walking towards this. I'm going to call this distance X because it's a horizontal distance. And I should see right away that there are some similar triangles. There's this big triangle and this little triangle, and because they have the same angle and the same angle and the same angle, they must be similar triangles. And so that'll give me the base for our relationship. All right, let's label some things. The man is 6. The street lamp is 18. Those are constants. They are not changing. X is changing because he's walking towards the street lamp. dx dt is equal to -3 feet per second because this distance is shrinking. And we want to know how fast his shadow length is changing. So that's just this length, S. So we want to know ds dt. And so we need a relationship. So let's set up a similar triangle. I'm going to not use this because this length is changing and this length is changing. I'm going to use a similar triangle with ratios here. I'm going to say S divided by 6 must be the same rate. So this side divided by this side, this ratio to this ratio, must be the same as the corresponding sides in the big triangle. So this side of this triangle is S plus X divided by 18. I'm going to multiply both sides to get rid of the denominator before I take the derivative on both sides. So 18s, I'm switching back and forth between cursive and print. I'm not really sure why. I think I should be using cursive so that my s's don't look like 5s. So I multiplied by 18 and multiplied by 6 on both sides. And I guess I could have multiplied just by 18 and gotten a common denominator, but I'm going to leave it like this. So I'm going to subtract 6s on both sides. 12s equals, wait, hold on, this should be an x. 12s equals 6x. And I'm going to take the derivative with respect to t on both sides because I know dx dt, I want ds dt. And so I'm doing d dt. And so 12, the derivative of s is just 1. So 12 times 1 times ds dt is equal to 6 times dx dt. Boy, this came out really easy. X is -3, so 12 ds dt equals -18. And so ds dt equals -18 divided by 12, which is 3/2 or negative 1.5. So that's the answer, negative 1.5 or negative 3/2. Let's see. Other tricky things. Yeah. Let's look at number 4. Number 4. Get some blue. There's a candy factory, and sugar is filling a conical tank. So there's a tank in the shape of a cone that is being filled at a rate of 3 cubic inches per minute. So this cubic inches per minute, this is a measure of volume. So dV dt, V because cubic inches, dt because it's per minute, dV dt equals 3 inches cubed per minute. Okay. What is the height? If the height of the cone, so this height is going to be h, is twice the diameter, so the diameter is there, so h equals 2 times the diameter. How fast is the height of the sugar in the cone rising when the diameter of the sugar filling the cone is 4 inches? Okay, so I am looking for how fast the height of the sugar in the cone is rising. So I want dh dt, cool. And so I need a relationship between V and H. So I know that the volume is equal to, the volume of a cone is 1/3 pi r squared times h. Now, I notice I know dV dt, I know dH dt. I can either take the derivative right now and use the product rule, or I can find a way to substitute r for h, because I don't know dr dt, and there'll be a dr dt if I take the derivative right now. So I always like to substitute at the very beginning. Now, I have a relationship between h and d, and I know the relationship between d and r. The diameter is 2 times the radius, so I can put that in for d. So h equals 2 times 2r, which is 4r. And since h is 4 times r, and I want to replace the r to just leave v's and h's, because I know dv dt and I know dh dt, but I don't know dr dt. I'm going to divide both sides by 4. R is h divided by 4. And so I can rewrite this equation as h divided by 4 squared times h. I'm going to do a little simplification. This is h squared divided by 16 times h. I'm going to put all my constants together. This is 1 over 48 pi times h cubed. This is all a constant, and so this is going to be a very easy derivative. When I do the derivative with respect to t, so I get dv dt and dh dt, I'll get the derivative of v is dv dt. Here, this is all a constant, so it's just a constant multiplier. The derivative of h cubed is 3h squared times, by the chain rule, dh dt. 3 divided by 48 is 1/16. Okay, now let's just plug some stuff in. dv dt, we already know, is 3 inches per minute. This is pi over 16 now, because I can cancel out a 3 and cancel out a 3, times, what is the h? What does it say? It doesn't tell me the h, but it says when the diameter is 4 inches, and if the diameter is 4 inches, then the height would be 8 inches, because it's 2 times 4. So h will be 8 squared times dh dt, and that's what we're looking for. So let's see. 8 squared is 64. 64 divided by 16 is 64 divided by 16 is 4. So we get 3 equals 4 pi dh dt. And so dh dt is going to be 3 divided by 4 pi. The units of this are going to be h is changing at the same rate as the diameter is, and this is going to be in inches per minute, because the volume was changing in inches cubed per minute. All right, I think I have time for one more. Let's do an angle one. Let me see if I can find an angle one. Number 9. Looks like it is an angle one. A balloon rises at a rate of 8 feet per second. So here's a balloon, and it is going up from a point on the ground 60 feet from an observer. So here's this guy. So this balloon is rising up, and it's rising up at, this is going to be, I'm going to call this y because it is a vertical distance that is changing. And so dy dt, how fast that balloon is rising, is 8 feet per second. The point on the ground is 60 feet from the observer, and this is not a variable. This is a constant. If the balloon is rising straight up, the observer isn't getting further away. Find the rate of change of the angle of elevation of the balloon when the balloon is 25 feet above the ground. So this is saying when y is 25, we want to know d theta dt. That's what we want to know. The rate of change of the angle of elevation. Here's the angle of elevation, the rate of change of that angle of elevation. So I need a relationship between the angle and y, because we know dy dt, and I don't want to include this because this is another variable that's changing and we don't have that, and it would make it much more complicated. So I want a relationship. This is a constant, so I can use that and I can use y. The two appropriate things would be tangent or cotangent. I'm going to use tangent. Tangent of theta is always the opposite divided by the adjacent. So y divided by 60. Or you can think of it as sine over cosine. Sine is the y value divided by the cosine. And so if I do the derivative with respect to time, the derivative tangent is secant squared of theta times by the chain rule d theta dt. Here, y divided by 60, it's being divided by a constant. That's the same as 1/60th times y. Multiplying by a fraction is the same as dividing by a number. And so this is just a constant multiplier. So there's no like quotient rule we have to do here. It's just 1/60th times dy dt. And so now I can evaluate. I know dy dt is 8. I'm looking for d theta dt. So I need to find secant of theta, and secant of theta is 1 over cosine. Cosine is the adjacent divided by the hypotenuse. So I do need to find this hypotenuse. And there's a right triangle here, so I know that 60 squared plus, in this case, y is 25. 25 squared has to equal c squared. I'm going to call this c. And so I'm going to use a calculator. 60 squared plus 25 squared. Square root of that is 65. So this must be 65 when this is 25, when y is 25. So the secant is, instead of the adjacent over the hypotenuse, it's the hypotenuse over the adjacent because it's the reciprocal of cosine. So it's 65 divided by 60 squared times d theta dt equals 1/60th times 8. And we can solve from here. D theta dt equals 1/60th times 8 times multiplied by the reciprocal 60 squared over 65 squared. I don't feel like simplifying this. I mean, I can do some simplifying. I don't know, it's 480 divided by, what's 65 squared? 4,225. I don't know what this simplifies to, but it's something. And let's see, this will be measured in radians per, what was it changing in? Second. All right, so that's what we got. All right, good luck on the rest of your homework.